the second technical session on the topic of conceptualizing and designing 21st century research libraries by Mr. Tom Cramer, who is the Associate University Librarian, Director of Digital Library Systems and Services, and Chief Technology Strategist, Stanford Libraries, USA. He is the architect and originator of the International Image Interoperability Framework, IIIF, and a leading figure in the development, deployment, and use of numerous digital library applications, including a suite of blacklight services, all of which are open source. Mr. Cramer oversees the development and implementation of Stanford's digital library services for digitization, discovery, delivery, preservation and management of digital resources that support teaching, learning, and research. Mr. Cramer also directs the Stanford Digital Repository, the development of EarthWorks, and the library's technical approach to its linked data infrastructure. Over to you, sir.
So today I'm going to talk, hold on, we'll get to slideshow. There we go. Today, I would like to talk about the conceptualization and design of 21st century research libraries, which is not exclusively, but is essentially a digital library. That is to say, you cannot have, I think, a 21st century research library unless it is innately digital and has all of the capabilities and affordances that you might expect and hope to do current day research, as both the materials and the methods of research, of teaching, and of learning have become increasingly digital. What I'd like to do is share some lessons and some observations from our development, or the development of our digital library at Stanford. I'd also like to share some philosophies that will extend on some of the things that Michael Keller has just discussed and the previous speakers from this afternoon. And then I would like to show some of the specific systems and interfaces and projects that we've developed at Stanford, which I think can be helpful illustrations of how we've applied some of these philosophies in actually trying to deliver value and create wealth, or the wealth of knowledge at least. Before I begin, let me just spend a moment talking about Stanford and our digital library. So Stanford University was founded in 1891. So we are still a relatively young university as universities go. We've just recently celebrated our 125th anniversary as a major one, and we continue to grow. It is a research university with 7 schools and covering everything from the professional schools of law, medicine, and business, but then also core sciences or core subjects such as humanities, basic sciences, engineering, education, and so forth. Within the libraries, we hold about 11 million physical volumes and 2.5 million ebooks, tens of thousands of serials, and we have nearly 15 miles of archival materials if you measure by the length of the shelf. We look at collecting archives, and manuscripts, unpublished materials are just as important as collecting the published artifacts. We also have multimedia objects with hundreds of thousands of sound recordings and more than 1 million maps and cartographic resources. From a perspective of staff, we have about 400 staff overall. Half of those are professional staff, so both librarians and IT professionals. And you'll note that IT professionals represent about 1/3 of the professional staff overall. We also have numerous paraprofessional staff who are engaged in things like technical services processing, access services, and the essential tasks of operating the library and moving materials. Overall, our budget is about $75 million annually, with about 1/3 of that spent on information resources. And through our collaborations and projects, we always strive to be innovating, and we often bring in additional funding for the sake of conducting innovative projects. If you'd like to, in the slide deck, if you'd like to follow any of these links, you'll see some of the critical systems that we develop and support. So our main library website, our principal catalog, which is called SearchWorks, how we support the discovery of individual articles in journals within SearchWorks, and a link to Spotlight, our digital exhibits platform that Mike mentioned, and I'll also reference at the end of the talk. Well, sorry about that, it clicked out. Okay, let's continue. No, the buttons are not doing what I'm expecting them to do. 1 second, please. Okay, here we go. So when we think of the development and the operation of a digital library, I think it's essential to think about the actual operation of a library. So what does a library do? You could break a library and the essence of its functionality and value down into the tasks that it performs on a day-to-day, week-to-week, and month-to-month basis. So essentially, libraries select resources. We acquire those resources, we catalog or describe them so that we can discover them. We hold the resources until such time as they're needed. And then when patrons arrive, we circulate the environment, or we circulate the materials. It's an essential component of our work is to preserve the items. So we're not just renting collections to provide access on a temporal basis, but we invest in collections over the long term. And finally, with our reading rooms and the spaces that we provide to scholars, we provide an environment where scholars can come in and interact. All of that, I think, is what a physical library does. And it's very important to recognize that a library is not a static thing. It grows and it breathes as both the materials of the collections and patrons come in and out on a daily basis. A digital library does all of these things and must do all of these things to support the same functions, but only in a digital realm. And I think one of the main things that I would like to stress is one can sometimes think of a digital library as an individual system, or maybe 1 or 2 systems. If we have a really good integrated library management system or catalog, if we have a lot of e-journals, if we have an institutional repository, we have a digital library. I don't think that's true. And in fact, I think that's a dangerous notion, because in essence, a digital library is not a system. It's a rather complicated and sophisticated ecosystem. It is a number of components that must work with each other, and that includes content, it includes technology and the systems and digital services that knit together, but it also includes the people in the institutions that provision and support those services, that technology and that content. And it includes commercial providers, because everything comes from somewhere, and commercial providers are an essential component of how we can source things. However, the commercial providers are not the only source and the only solution. And in fact, a big tenet of Stanford's library development has been that the commercial marketplace has not provided all of the solutions that we would like to see. So we often find ourselves in the position of developing our own systems, or even more importantly, developing communities who can pursue novel systems and valuable systems and digital library services together as a community. In my time, I think that there are 3 large lessons thinking about designing for digital libraries and building, operating, and planning for them. The first is coherent with this with this ecosystem theme, is it's absolutely essential to design for interoperability. Digital library content and digital library systems, even the staffing that are within libraries, you must think about how you can connect those different components and how you can reuse them in different contexts and reuse them over time. So instead of thinking about an institutional repository as a standalone system, it's really essential to think, in my view, about how an institutional repository can connect to your integrated library management system, how you can bring content in from various places, or how you can bring content from your institutional repository into other systems, such as your catalog, and how you're going to preserve all of this content in your long-term digital preservation systems. The second thing that I think is essential for libraries is that we are here for the scholars of today, as well as the scholars of tomorrow. And when we put systems or content in place, we don't expect those just to last for 3 years or to 5 years and then to go away. So we must think about and design for the axis of time. And that is, there are two important facets there. The first is when we develop something at the beginning and release it, it's important to plan that this is going to evolve over time, that we're going to enhance it, that will add more functionality, that will add more connections, or that will add more content over time. It's a mistake to think about building a system that is closed and something that would have a finite amount of content or a fixed amount of content or functionality or lifespan. The second is we are in this for the long haul. Unlike corporate systems, unlike individual research projects, which have a beginning, a middle, and an end, libraries are here and should be here over the centuries. So the work that we are doing today is the seed for much larger work and long life work that will be here decades from now or centuries from now. So as we develop our systems, we always have to think about the future being in mind, and we always have to have not just an exit plan, but a sustainability plan, so how we can move our content and systems into the next environment. So especially critical in a digital realm where the half-life of individual systems is often measured in a span of a handful of years. So how, as I develop this system today, how can I move that forward into the future? What will its replacement be? The last thing that I think is critical is because this is such a period of foment and innovation, is such a period of change within the information landscape and within libraries themselves, is we have to always be building capacity. Every service that we offer, every system that we design, every partnership that we make needs to be a strategic one that is building the capacity of our individual institutions to offer library services. And I think most importantly, that's really about building up our people and our staffing resources. It is the people and the staffing resources that ultimately that are the most essential for having a successful digital library. They're the ones that understand the strategy. They're the ones that understand our users. They're the ones that understand the complex ecosystem around us of content and IT systems and how they can all knit together. Building our capacity and not waiting for other people to step forward and do it for us is absolutely essential for empowering ourselves to provide relevant digital libraries and relevant library services now and in the future. About 15 years ago or 16 years ago, one of the common refrains in libraries was, if everything is on the internet, why do you still need a library? And Mike talked about the fact that not everything is on the internet. One of the things that we heard at Stanford, which is right next to Google and was the founding place of Google, was why not just use Google to search everything? And why should libraries do anything at all if you can just look to an internet firm or a startup that will come in and innovate more? Well, of course, what we've seen over time is that Google's interests and Google's strengths are in fact quite different from our interests and from our strengths. And so it's been important that we persevered over those years and continue to develop our own search technologies, our own preservation technologies, and thinking really about how we can add value to our scholars, both our researchers, our teachers, and our learners in the course of their work. So some major design principles and some tenets of Stanford and our digital library infrastructure are laid out on this slide. So in the first place, we always want to consider all formats of information. We don't only limit ourselves to, say, ebooks or e-journals, but we look at any way that information might be conveyed. The second is we look at the full life cycle of information, everything from the planning and the creation and the research of the life cycle, all the way of information or of data, all the way through its management. So making sure that you have appropriate rights information, that is fully described, and then through its access and preservation. So in terms of access, we think about both the discovery as well as the delivery. Can people get it to their individual environments? And for preservation is the information that we're provisioning going to be accessible in 5 years, in 50 years, in 500 years? The next tenet that we really pay attention to is that of collaboration and both open source software and open data. As I mentioned earlier, at the beginning of the development of the Stanford Digital Library, we surveyed the landscape and we said that the commercial space really wasn't offering many of the solutions that we were looking for. The innovation wasn't there, the fit to the library marketplace wasn't there, the special needs that a research library and a research university just weren't being addressed. And so what we found is that we were often in a position of developing our own solutions and our own software, but that's actually quite expensive and quite risky. What happens if you are banking on one or two key people and they have a career change, or they leave or they retire? What happens if you actually end up hitting a dead end because you are smart people, but you guessed wrongly? Or what happens if you simply can't scale up because many systems and many services require more than just a handful of people? Open source software, open data, and collaboration have been our strategies for not just pursuing these solutions and these approaches individually, but instead finding a community of like-minded institutions, of like-minded people, and of very smart people at other institutions, both in the United States, but also internationally. Frankly, that's one of the reasons I think that this, our engagement and our partnership with the Geo Institution is so fascinating, because the wealth of talent and opportunity that come with working between a US institution and Indian libraries. The fourth tenet, or the fourth thing to focus on, there are a set of core systems that enable absolutely everything else in a library. And so I'll talk about those, but that is basically the integrated library management system, which handles the physical transactions or the management of the traditional library. And it's the digital repository, which is the core to storing all of your digital assets that you've accrued over time. Along with your core systems, there are a set of specialty systems which must be developed and adapted to meet distinct needs. And I'll give you some illustrations of some of those. So I'm talking about specialized catalogs, I'm talking about delivery systems, I'm talking about digital exhibit platforms. Finally, one of the things that we are always doing and represents at least 20 to 25% of our work is looking forward. What is the next trend? What is the next need within our research university? What are people prioritizing or developing now? And just as we're delivering services that we developed 10 years and 15 years ago, and we're keeping those up to date, we're also always keeping an eye on what is developing in the future and allocating a good part of our resources into thinking about how will we build capacity, how will we build systems, how do we understand what will be needed? And I'll give you some examples of that. So to go into a little bit more detail, libraries are, of course, not just about books or not just about journals. So within a modern research library, it's really critical to support all formats that your scholars, that your researchers may be working with. So that can include electronic theses and dissertations, books, articles, images, audio-visual materials, both sound files as well as moving image. It definitely includes research data, which is vastly expanding and growing. And I think the relationship of libraries to research data is a very interesting one at this point in time. In 10 years, we may say, thank God the library was involved in our research data efforts. Or in 10 years, people may be saying, why would you ever go to the library if you needed research data? That is up to us right now to try to figure out how relevant we will end up being. A different type of data are maps and geographic information systems, or GIS. For us, we have a map library, and this is essential functionality for us. This is one of our primary areas of collection and delivery. It also includes things like typical documents. So Microsoft Word documents or Excel files, PowerPoint. We are increasingly collecting things that are born digital materials, including things like email archives. And finally, the web is absolutely emerging as the form of scholarly communications for the 21st century. And as such, because we are a research library, we find ourselves increasingly collecting and offering archive websites as part of our materials. This slide, if we wanted to, you could come up with another 5, 10, 15, 25 different types of materials that are important to collect. Because not everything is born digital, we have developed over the last 15 to 20 years at Stanford really robust digitization capabilities. Excuse me, I need a little sip of coffee, apparently. So for us, that includes both what you would expect. So we scan books, we scan archival materials, so old paper files, but we also scan some things that you might not expect. So you can see imaging of three-dimensional materials. That's the jaw of a Paleolithic bison that is being scanned within one of our labs on the top left. We also have a legacy computer media, and you'll see one of our born digital curators holding up a 5¼ inch floppy drive, which is something that we have captured from the legacy media and moved into our digital library. We have extensive development or extensive digitization capacity for moving image materials, moving image and sound materials. We do very large format and rare and special collection materials, such as this vintage map of Africa. We've even looked at automating the throughput and increasing the throughput of materials. So we have a page turning robot, which will actually, if you put a book or a newspaper on the bed of this device, it will lower a glass panel, it will take a picture, the glass panel will raise, and a vacuum arm will lower, come down, grab the page, and advance it by one page. And with that, instead of a single operator scanning 1 to 2 books per day, we're able to do 50 to 60 books a day with 1 to 2 operators. We're also finding that digitization is actually quite a current and relevant skill set and domain for Stanford students. So this is Tony Calavano. He's one of our digitization lab experts at Stanford. He regularly attends the archaeology courses and seminars and gives an overview about how digitization works and how people can do field digitization for archaeology. For us, this is a critical strategy and a critical component of our digital library, and we use it for collection development. There are many things that are available that we could acquire digitally, but we could never acquire physically. Mike mentioned the Parker manuscripts from Cambridge University. It's about 575 Anglo-Saxon manuscripts that are hundreds to over 1,000 years old. We would never be able to acquire any of those manuscripts, but through digitization, we've been able to surface those and make them available to Stanford scholars and scholars of the world. We also, digitization allows new forms of digital access. So think about text mining or data mining. These are things where instead of close reading a novel, you can think about distant reading or reading 10,000 novels at the same time to look for linguistic or literary patterns. There are specialized research projects where we might digitize maps and georectify them to see how the cartography of an area has changed over time. And of course, digitization is an essential strategy for long-term preservation because even physical objects decay over time. In addition to digitizing, we also make a great effort to capture contemporary information that's produced digitally as it's being produced, rather than coming back to try to collect it later. So in 2009, we launched an electronic theses and dissertation system at Stanford, and it is completely optional, but we find more than 99% of Stanford degree candidates make use of this system rather than going through the traditional method of printing out your dissertation, binding it, and submitting it as part of your filing process. Dissertations, theses and dissertations, we have found is one of the most important and most sought after areas of our collection. If we look at the catalog statistics and what people are looking up, the single greatest category is our ETDs. So this is an area by setting up a electronic thesis and dissertation deposit system. We've been able to build an important collection over the last 10 plus years, and all of that is born digital. It's a great service to our scholars, and it really helps them with having their work get circulated and distributed, contributing to the commonwealth of human knowledge, but then also helping preserve their work and make sure that they get credit and visibility for their thesis or their dissertation. I mentioned the acquisition of websites. About 8 or 9 years ago, we started building up our capacity to archive websites. And if you look in our catalog today, you'll find that we have over 3,000 websites that we have crawled, that we have captured, and that we have brought into our local digital repository and into our catalog. Now, we use a variety of methods. We use the Internet Archive and the Archive-It service, and we also do local crawls and local captures and load them in. In all cases, we really appreciate the community approach to crawling and preservation of our websites, especially the Internet Archive. But we also want local copies, so we can do things like data mining, text mining, and we can be sure we have a copy even if the Internet Archive is unable to offer those services or continue to offer access to what they've captured over the years. We've also built up a system to acquire, in the same way that we acquire books or journals, digital monographs. So if someone has published a PDF, or if there is a government document or technical report that might be considered gray literature that's been published on a website or is being circulated via email or other means, we have equipped our technical services librarians with a system where they can capture that PDF, they can upload it, they can describe it with appropriate metadata, and it becomes officially part of our library's collections. We call these EAMs, or everyday electronic materials. And over the years, you can see that while we started off in a pilot mode, things have simply spiked. And if this continued, the last data point here is 2017. But if you continued plotting that, it would go up into the hundreds per year. Just going to do a time check here. One of the other tenets that I mentioned is it's important for a digital library to think about not just amassing content or not just delivering the content, but really supporting digital content through the first cycle, through its full life cycle. When we think about digital libraries, we think about 3 different sets of concerns. So the first is content. So all of the things all the formats that might be digitized or born digital. We think also, because it's digital, you have to have services that understand, deliver, and manage that information over time. This is the technology, the technology and information technology. And then finally, you have to sit on a set of infrastructure. So that might be cloud-based, or it might be a local machine room with servers, storage, network, accounts and authentication to let you log in and be able to see things. When we think about the services in a digital library, at Stanford, we're thinking about everything. So starting with digitization, or the deposit of born digital materials, how we manage that, how we make sure that we understand and apply rights and access control, long-term digital preservation to make sure that what we're bringing in today is we can do things like format migration, fixity checks over time. We also think about how can we publish information onto the web. An increasingly important function of libraries and digital libraries, especially from institutions, is to take content that's coming from individuals or small groups and put them onto the web and make them part of the global network of knowledge. It's often very hard to do that for individuals. They may come and go. It's difficult to get them to be able to be indexed by search engines and discoverable. So as an institution, a critical thing that we can do is surface this information and be part of the dissemination process. Also, there's, I've mentioned access is both discovery and delivery. And then once material is up, analysis of the entire environment and analysis and digital curation of the materials is essential. We have also, and I've mentioned this, really focused and emphasized on the development of community, and that's through open source software, it's through open data, it's through international collaborations, and it's through partnerships of various institutions. And I'll give you one example, which has been mentioned a couple of times. This is a snapshot of the level of involvement in the International Image Interoperability Framework, or IIIF, as we say. IIIF is a strategy for surfacing digital images on the web in a way that any other institution can use them in a really robust manner. So that means through a common API or application programming interface via the web, a scholar from anywhere in the world could look at a digitized book or a manuscript or a map or you name it, and they would be able to load that into the software of their choice. They would be able to incorporate that into their own library environment. They could use an exhibit. They could load it into a course management system and be part of a course. And all of this supports annotation, which might be by an individual looking at highlighting regions of interest or applying textual annotations, or it could be through a group or for an exhibit. This was something that originated at Stanford in 2011. And one of the first things that we did is identify who else in the world shared this concern and who else might share in the development, not only of the interoperability framework, but also surfacing their content and developing software that would add to this global commons. And you can see two things. One is a set of maps or a map that shows the level of contribution and membership across the world. And you can see we have institutions almost everywhere that have been part of this development. You can also see a heat map of open source software development where pull requests and code contributions have been coming from. So instead of having a single institution or a single developer at a single institution, we're seeing these real spikes with library development and library contributions to Mirador, which is an open source viewer. Started at Stanford, but I'm quite pleased to say is no longer limited to Stanford and is used across the world, but also contributed to by developers from across the world. It's a really powerful example of how working together, we can create a much richer environment and ecosystem, not only for ourselves, but for everyone. I also want to talk about people, and Mike Keller mentioned some of the roles and some of the functions in terms of a team that are essential for developing a digital library. So obviously you need technologists, but you also need subject experts, you need curators, you need library administrators, and you need partners. So we often don't think about IT people as library people, but I would argue that they in fact are, and these are critical roles and critical components of any library and any library ecosystem. So everything from system administrators and operations engineers, which help run the data center and the machines in it, all the way to data managers, service managers, and project managers who are developing digital projects. Of course, there's software engineers, and then you also have user experience designers and your subject matter experts who understand the technical services processing, the researcher needs, as well as the content. Now, I mentioned a little bit the core systems that are really integral to any digital library, and there are two. Oh, come on. There are, this is an example of what a digital library environment might look like if it was fully fledged. So you have, with content generally flowing from left to right, you have various input streams such as digitization or digital acquisitions, new forms of research data, specialist format acquisitions like web archives or geospatial information. These are registered in the large systems. So this is the integrated library management system and your digital repository. You might also have some specialist management systems like an archival management system, which is like an ILS, but for archives. The content in these is often indexed into a general discovery index, and then they're presented through front-end user interfaces like library websites, or your catalog, your digital exhibit software, or specialist discovery and delivery environments like ArcLight, which is I will talk about, but is a black open source software called Blacklight way of discovering information in catalog or in archives, or GeoBlacklight, which is the same thing but for geospatial information. The integrated library management system is really important to consider in developing and designing your workflows. It holds all of your user information, so who is eligible to make use of library services, but it's also all of your technical services processing for both content, physical content, so the books and the journals that you might hold literally tangible copies of in your library, but also the digital copies. So what are your e-journals that you're licensing? And what are the catalog records for the material that you're bringing in, digitized or born digital? Of course, part of this, an essential part of this, is e-journal access. I will say, in thinking about how the integrated library system market has developed over the years, there are two really nice open source systems that have developed or are developing. So Koha and Folio, and I think you're going to hear a little bit about Folio later this week. Stanford has committed to Folio, and we are in the process of migrating to it. It's very exciting for us. There are also a number of commercial systems which are a little bit more closed. They're a little bit more in the box. They're a little bit more expensive. We've found those limiting, and so we're excited to be moving forward with Folio. The other environment that is really essential, the other pillar, is the digital repository. And this is responsible for the management of your digital assets. So that's everything from accessioning them into the library environment to arranging, transforming, and versioning them over time. It's also about the preservation of this content to make sure it's available over the long term. And it presents in our architecture and many different environments. The digital repository presents the information to specialized access environments. So that could be your discovery environment and the indexes that support that, but also download, streaming services, and applying access control. And for us, one of the critical leaps that we made is that we didn't want a different digital repository for each type of content. We didn't want an institutional repository, and then a streaming media repository, and then a GIS repository. So we have developed a general purpose digital repository, which is called the Stanford Digital Repository. And its job is to manage and support all of this content through preservation, management, and access. It's been running now since 2006. It has over 2 million unique digital objects and more than 1.1 petabytes of unique data. We've also opened up deposit interfaces, so our electronic theses and dissertations application, for example, comes directly into the repository. And we have had thousands of depositors from more than 2/3 of the departments at Stanford make use of the repository. So it really has become an integral tool that is part of the scholarship and the administration of the university. I do want to just underscore the importance of digital preservation, as we ignore this at our own peril. On the left is a picture of the Domesday Book. This is the census of England that William the Conqueror did after conquering England, shortly after conquering England in 1066. It is still legible today. And if you look at this pretty old iPad now with an old version of the Apple's library or book library, you'll find out if you tried to read that now, it's quite likely that you would not be able to access the content that you acquired, and that would only be 10 years old. You would have to load that content into special software, you would have to break through the DRM, you would have to forward migrate it and put it onto a current platform. So it actually requires a fair bit of work to make sure that the digital content that we're bringing in today is going to be available. Now, I've mentioned the core systems, and I want to give some illustration of some of the specialty systems. Discovery is absolutely essential to any environment. So at Stanford, if you go to searchworks.stanford.edu, this is our general purpose catalog. And you can see a typical faceted browser and faceted search interface. And you can search all of our books, all of our electronic holdings, and you can drill down specifically into articles, where we have a separate feed from EBSCO Discovery Service with their large-scale article index. Now, instead of using EDS and their native interface, we thought it was important to have our scholars see both our books and our journals next to each other. So we use the EDS API or a feed from EDS to support SearchWorks. We also support a bento box discovery environment, so you can search not just books and articles, but you can also search our website. You can search our digital exhibits, and you can search other specialty environments such as which is a conceptual search engine. All of our catalogs and our discovery interfaces are based on Blacklight, which is an open source project based using Ruby on Rails. It's very well established, really rich community of developers that are supporting it, as well as Solar, which is an underlying index. And we have spent a lot of time integrating our catalog with the integrated library system, which holds the user account information and supports requests and holds, as well as our library website. EarthWorks is another example of a specialist catalog. This one is really customized just to geospatial assets and geospatial materials. So this is scan maps and geographic information systems, or layers. And one of the exciting things about EarthWorks is that because of our emphasis on collaboration and open data, you can not only find Stanford's content, so in this screenshot, there are 14,000 different layers or different geospatial assets that are accessible in EarthWorks, which is our catalog. You can also find those of other institutions, so tens of thousands from Princeton, Harvard, MIT, NYU, and Columbia. And so essentially these other schools have described their materials, and because they're digital, many of them are accessible. If they're not licensed, if they're open to everyone, many of them are accessible to scholars at Stanford. So what they have done is made their metadata accessible to us and to the entire community. We grab that metadata and we index it and we load it into EarthWorks. So Stanford scholars can not only find about 14,000 Stanford items, but they can find tens of thousands of items from a consortium of like-minded institutions. It's a real example of the power of using digital and collaboration. I mentioned archives and manuscripts, so we have about 15 miles of archival materials. ArcLight is a system that we've been working on for the last several years that provides really rich and intuitive discovery of finding aids, which is the typical method of organizing and describing archival material. And then we've also interleaved or added in a digital object viewer. So if any of the materials or all of the materials have been digitized, you can see both the finding aid as well as the digital assets as part of it. Mike mentioned Spotlight. I'd really like to underscore this. So Spotlight is a digital exhibit platform. This is also open source. It also is based on Blacklight. The light is a giveaway there. What we found as we were developing, so if we have 2 million digital objects and a petabyte of materials, you can add lots and lots of things to a library, but at a certain point it becomes overwhelming and people want to see a subset of information and they want to be able to see that information in context. Spotlight is an open source tool that excels at doing both of those things. So through the creation of digital exhibits, curators, students, faculty members, and researchers can select any subset of materials from our digital repository or load materials from other environments and other institutions via IIIF into Spotlight. and they're able to create their own context. They're able to arrange the content in whatever order that they like, and they're able to write essays and provide narratives that let people interpret and understand what's being presented. This is become absolutely the killer application for us because it allows people to develop and deliver these digital exhibits and these narratives without having to do any sort of development at all. It's a really powerful leap. And I think 10 years ago, if there was a do-it-yourself platform for digital library sites, it would have saved us tons and tons of effort, because what would happen is we would digitize a set of materials or a special project, and then we'd have to have a team of developers working for 3 to 4 months at a time for a single product. And then that single digital library website would end up aging over time and would need to be replaced after 5, 6, or 7 years. So it was really hard to do more than, say, 5 or 10, even with a very good sized team. Now we have a single platform, we have one team that spends part of its time supporting Spotlight, and we have, we're approaching 200 digital exhibits. It's fantastic. If you have not developed this kind of capacity, and if you are interested in this, I definitely encourage you to take a look at exhibits.stanford.edu and to look at Spotlight. I mentioned a part of the activities of our library, and I think any library and any digital library should be looking forward. And I want to close with kind of 2 big themes that I see are coming up and are very important at Stanford. So the first is research data, and I mentioned this at the beginning. Now, libraries have been collecting data that's been used in research for decades, especially in the social sciences. We have decades of materials like old censuses, statistical analysis, those types of surveys. And so it's a relatively mature function. We've also been doing it with geospatial data for almost 2 decades at this point. But data is now everywhere. It permeates every discipline, it permeates every domain, and it is part of all research and all teaching that is happening at the university. One of the things, the traditional view of data is that's something that you generate so you can write an article, and the article was the important thing. That mindset has completely shifted over the last 10 years. Data is now looked at as a first-class output of the research process. Data is essential for people to be able to reuse that data, whether they want to use it in a new study or if they want to reproduce what you did as part of the scientific process to validate your results and your claims. A big challenge that we have is that until recently, data has largely not been retained. It hasn't been curated, it hasn't been preserved, and the data from 10 years ago or 20 years ago is no longer accessible. I think it is an essential role of libraries to reverse that course, and it is up to us as memory institutions, as curatorial institutions, to understand the data that's being produced, what's valuable, how should that be described, and how can that be carried forward through time so that future researchers and current researchers outside the immediate group can make use of it. This is a quote from one of our senior faculty members, who's a statistician, who talks about how important depositing her data and her code in the Stanford Digital Repository is. It's also important because increasingly we're seeing the funders of science and the funders of research are demanding that publicly funded data be publicly funded research that produces data, that data be publicly accessible. So we've seen since 2013 in the US, the Office of Science and Technology Policy, part of the White House, they issued a sweeping memo that's basically said all data from publicly funded research will become available. And we're seeing over the successive 9 years that really has come to be. So for a major research university like Stanford, we understand that if we're producing data, but we don't have the mechanism for our researchers to share that and make that publicly accessible, they will actually be at a disadvantage in applying for grants or conducting modern research. So for us, this is an essential part of the role of the institution and also the library within the institution. One of the approaches that we have just recently begun to take, and this echoes what is happening at institutions like Harvard and Princeton and MIT, is the development of a data commons. And the definition of a data commons, this comes from the NIH, or National Institute of Health, which they had an initiative called the Data Commons Consortium that ran from about 2015 to 2018. And what they were doing, instead of building a single platform for data and a single system that would house all data, they were working on building an ecosystem that I talked about earlier. So they were especially emphasizing the use of cloud compute infrastructure, and then they're looking at, with a cloud-based environment for compute and storage, can I bring commonly used services, tools, and applications together that are applicable for the full lifecycle of data? And can I use those commonly used tools and services to create an interoperable resource for managing, analyzing, and sharing data? At Stanford, one of the ways that we've thought about this is, how could we bring library-based systems like the Stanford Digital Repository, or a catalog for data, or EarthWorks for geospatial catalog, together with high-performance research computing. So at Stanford, those are systems like Oak and Nero and Sherlock. Or could we bring it together with environments like Amazon Web Services, Google Cloud, or Google Drive? And can we use a system like Globus, which is high-capacity data transfer, to get data all around the environment? So instead of putting all of our data into, say, the digital repository, which wouldn't be possible because there are petabytes and petabytes of research data at Stanford, or instead of keeping all of our research data, of which there are petabytes and petabytes, in our high-performance computing cluster environment over time, which is also not tenable because it's too expensive, and that's not what those environments are for, how do we move data across this honeycomb over time? And as we start to think as a library at Stanford, how do we make these connections, say, between our digital repository and the high-performance computing environment? Over time, how can we add more and more honeycombs from the different departments and service providers on campus? And we think that that is an intelligent approach to making sure that what we're developing today from the library will intersect with the research data environment and the research data computing infrastructure that is developing across campus. Where we are focusing right now for a Stanford Data Commons is on enhancing the Stanford Digital Repository to support research data, the development of Globus and the support of Globus as that high-capacity data transport across the institution, Rediviz, which is a data exploration device for tabular data, which is cloud-based, and we're working on developing a data catalog. So once data has been produced or data has been acquired at the university, we can describe it and then present it so it's accessible to other people at the university. Believe it or not, we have multiple cases where Stanford researchers have gone and purchased data from an external provider and brought that into their lab and used it. Another researcher at the university has gone and purchased that exact same data, brought that into a different part of the university and used that. And in many cases, the data was licensed so other people at the university could use. They just simply didn't know that it had already been acquired. And we're seeing that this will be an essential function of the library and a data catalog moving forward. The second major trend that I just wanted to highlight, which plays very well in with the GEO mission and the GEO's developing departments, is the application of artificial intelligence for libraries. I have helped create a new group called AI for LAM. It is an open community, and it is focused on understanding and applying artificial intelligence and machine learning for libraries, archives, and museums. There are about 250 people in this open community. We have monthly calls, we have working groups, we have a project registry, and we have a website and working groups where we are collectively trying to understand how machine learning will relate to libraries and how libraries will relate to and support machine learning. And I think there are three big trends that I'm seeing here. The first is our researchers who are doing AI, they need data. It's the thing that is the hardest to get. It is the thing that takes the most time to organize and to polish and refine so it can be fed into these machine learning algorithms. This is a great opportunity and a great area for libraries to be involved as we think about gathering data sets, gathering training data, gathering ground truth data that can be used to train algorithms and to test algorithms. What better place than a library with our hundreds of years of curation history might there be? The second thing that I'm looking at is it seems it is inevitable, and in fact, it is already happening, that machine learning and artificial intelligence will become essential parts of the data curation workflow for our own digital libraries as we're bringing content into the library, as we're looking to do things like transcribe or closed caption streaming media, as we're looking to preserve data. Increasingly, machine learning and AI will be core components of how we go about our work. So it's incumbent upon us now to really understand AI and how it's being applied. The third thing I would say is that there's a real opportunity and need here for libraries to understand AI so they can bring the ethics and the values and some of the tenets of librarianship into the artificial intelligence domain. If you've done any reading or if you've been watching this space, you'll know it's pretty mysterious. The way these algorithms work, no one understands. It's beyond human comprehension. But the data that's being fed to them will introduce specific bias and will lead to some surprising conclusions. Libraries, through their commitment to transparency and reproducibility and democratic access to material, are in a very important role to understand how we can bring those same values and make sure that they are applied to artificial intelligence as things move forward. Because it is unlikely to be the corporate interests, which they have an incentive and they don't have the structures in place to be able to be open or completely sharing of how they're going about training their algorithms or what data they're using. Libraries are in a good position to be a counterpoint. So I invite any of you who are interested or already active in artificial intelligence to go ahead and look up AI for LAM. If you go to aiforlam.org, you'll find the site, and please feel free to sign up for the group, and maybe we'll see you on one of these calls.